and welcome. My name is Shannon Kemp, and I'm the Chief Digital Manager of Dataversity. We'd like to thank you for joining today's DM Radio, our data lakes for business users, sponsored by Arcadia Data. It is a deep dive and continuing conversation from a live DM Radio broadcast a few weeks ago, which if you missed, you can listen to it on demand at dmradio.biz under podcasts. Just a couple of points to get us started. Due to the large number of people that attend these sessions, you will be muted during the webinar. If you'd like to chat with us or with each other, we certainly encourage you to do so. Just click the chat icon in the upper right-hand corner for that feature. For questions, we'll be collecting them via the Q&A section in the bottom right-hand corner of your screen, or if you like to tweet, we encourage you to share highlights or questions via Twitter using hashtag DMRadio. As always, we will send a follow-up email within 2 business days containing links to the slides, the recording of the session, and additional information requested throughout the webinar. Now let me turn the webinar over to Eric Kavanaugh, the host of DM Radio, to introduce today's webinar and speakers. Eric, hello and welcome.
Hello and welcome, everybody. Thank you, Shannon. Yes, indeed, it's time for another DM Radio Deep Dive. My name is Eric Kavanaugh. I will be your humble, if excitable host. And let's dive right in. Our data lakes for business users. Obviously, that is a slightly rhetorical question. The apparent goal, I think, for any organization is to have that answer be yes. Of course, that's what we want. So featured speakers today, Steve Woolidge of Arcadia Data, of course, yours truly in the middle there, and my good buddy, Wayne Eckerson of the Eckerson Group. He and I go way, way back to the old TDWI days, so we've had a long history together, focused on things like data warehousing and now, of course, data lakes. And as a concept I'm going to touch on very quickly before I hand it over to Wayne to give us some results from his assessment, and that is this whole concept of data science. We keep hearing about data science. This is one of my favorite quotes from the movie Nacho Libre. That's Esqueleto, who claims, "I only believe in science." Right? We hear all about science these days and data science as well. We all know that numbers don't lie, but they sure can be misused or misrepresented. But I wanted to point out just a couple of quick things to keep this whole topic in perspective and what we're trying to accomplish here today and what we're trying to accomplish in the broader business intelligence, analytics, big data market. We're trying to use data to get insights to be able to make better decisions for our business. The mission is the same. The mission has not changed. The tools have gotten much more powerful. We now talk about data lakes as opposed to data warehouses, and they are, in fact, very different things. They're designed very differently. They were developed in different eras of this industry. And let's face it, there were a whole set of constraints many, many years ago when data warehouses were designed around which they were built. Processors were slow, pipes were thin, for example, memory was expensive. So all of these factors really dictated what had to happen in terms of creating data warehouses. They were also extremely expensive. If you compare a data warehouse deployment today versus one 25 years ago, it's astonishing the price difference. We've gone from millions of dollars to hundreds of thousands of dollars to even $100,000 or less, depending upon the use case and the complexity. But I want to point out that communication is hard to do. I think people take communication for granted, and at the end of the day, if you're not communicating clearly with your team, with your business users, what it is that you've learned, what you've gleaned from the data, then really you've been on a fool's errand. And so that's something to be considered here. So science, data science, I think it is applicable these days. I think that is an accurate term that we can use to describe some of the more robust, well thought out, and efficient environments for managing data. But I think there's a significant disconnect in our culture today when we think of this term science. I think a lot of people believe that science represents a virtually infallible version or representation of reality, and that's just not true at all. Science is a discipline, and it relies on a methodology, aka the scientific method, which, if applied appropriately and effectively and efficiently and responsibly, can give us great insights about the world around us. But remember, axiomatic to the scientific method, fundamental, intrinsic to the scientific method, is a commitment to forever question your data, your processes, your hypotheses, and even your conclusions. So again, my point is that we need to take the term science with a bit of a grain of salt here. And scientists change their minds. One of my favorite references is this whole story about eggs being bad for you. Remember how it really hit a fever pitch about 10 or 15 years ago. Oh, the cholesterol in eggs, you're going to get a heart attack. And then what happened? Then they came out with good cholesterol and bad cholesterol, right? Okay. What does that mean? I think the point is that scientists will change their minds about things, and scientists, frankly, can also be paid by large organizations to say things that they probably believe, but are then used to distort what is the reality that we're all trying to better understand. So as just one quick example of how much we really don't know these days, when will the lava flow stop in Hawaii? The answer is we just don't know. And the reason we don't know is because the Earth is a really large environment, and things like volcanoes are extremely hard to predict. They're very powerful, very complex, and we just don't fully understand what's going on. The magnitude of the problem space, if you will, trying to understand where the lava is going to flow, where the fissures will come from next, what that volcano may do next, we just don't know. And so I think it just pays to remember that data will always require analysis. No matter how efficient you are with a data lake management project, for example, you're still going to need to analyze that data, to put it into context, to view it in reference to your current situation, the historical data that you may have. No data is ever going to give you the complete and total answer of the story because you have to come up with a story yourself. So leveraging what you know is important. It takes savvy, it takes moxie. Analytics and big data are all very useful and valuable if we understand what we know and know roughly what we're doing. And so with that, I'm going to hand it off to my good buddy Wayne Eckerson, who is going to talk about the assessment that we've done on behalf of Arcadia Data and our end users about Data Lake and the value that it provides for business users. So with that, Wayne Eckerson, I hand it over to you.
Thank you, Eric. It's great to be here with you once again, and Dataversity, and everyone in the audience. Whoa, that didn't work. That image
like
for some reason is not showing up. That's image of a data lake. And
hey Shannon, can you flip over to the other one for him? You're gonna have to take. But there you go. Okay, take it away, Wayne.
Good. Yeah, all right, so there's the data lake. Yeah, so this webcast is about the business value of data lakes. And as Eric mentioned, data lakes arose a number of years ago, almost 10 years ago when Cloudera was founded, really to address a lot of frustration on the business side with the data warehousing. As Eric mentioned, too slow, too hard to design, too hard to change, very costly. Scalability capped out at a couple terabytes, really. Didn't really handle unstructured data very well. So fast forward to the data lake and Hadoop, and that made a lot of people happy. However, it did not replace the data warehouse. What the data lake became, in essence, very quickly, was not a data warehouse replacement, but really an ultimate ideal sandbox for data scientists or power users who really wanted what they've always wanted historically, is a big giant data dump. And then to get IT out of the way. And a data lake essentially was that, just put all the data in one place and then let me go in and navigate it and manipulate it and manage it and analyze it. And create models from it. So the data lake really in its first incarnation turned out to be great for data scientists and data analysts, power users who wanted access to the raw data. It really wasn't a replacement for a data warehouse that supported standard dashboards and reports for, I would call, casual users, executives, managers, frontline workers, who really needed tailored access to information. So, we've asked recently when we got together with Arcadia, what about data lakes and regular users who don't know SQL, Python, or Java, which are the tools of choice for Hadoop type processing and analytics, who need a graphical interface to analyze data, also known as a BI tool, who require clean, curated, aggregated data. In other words, someone, typically in IT, to go in and take the raw data and then manipulate it, so clean it and integrate it so that the casual users can make sense of it without having to do all that manipulation themselves. and who need sub-second performance, query performance, and views of data in reports and dashboards that are highly tailored to their needs. So they only see what they need and nothing that they don't, with predefined drill paths that really meet their needs to glance at KPIs and take action if things are awry. So my hypothesis, frankly, is that data lakes have not been a good thing for regular users, regular Joes, if you will, executives, managers, frontline workers, even customers and suppliers. But we got together with Arcadia and decided, let's test this. Let's do an assessment and figure out if this is still the case, if data lakes are still just for power users or not. So we did an assessment. We came up with a survey of 22 questions. It took about 5 minutes to complete. Once they completed it, Eggerson Group assessments or surveys generate a dynamic report, as you can see here on the right. Highly personalized. It gives them a score, compares them to everyone else overall and by category, with recommendations for next steps based on their rank in the scoring. So that assessment is still running now, and I encourage you to go out and take it at the link below to assess the value of your data lake, if you have one, for your regular business users. So as of April 20th, when I put these slides together, almost 200 had started the assessment, 162 had completed it. 93 have a data lake in production, and those are the folks that we really wanted to focus on. Of those, 74% were from North America, and about half were fairly large organizations with more than 10,000 employees. So the data that you'll see here in the charts I'm going to present is based on that subset of the respondent base. I think we're up to almost 250 respondents now. We'd love to have you get us up to 300. So write down that URL and go. It only takes 5 minutes or less to complete the assessment, and you get your own personal free report. So what did we find? First of all, surprisingly a little bit, is that for data lakes, most people, almost 2/3, are using Hadoop for the data lake. And I suppose that's not too surprising. Data lake has become synonymous with Hadoop, but in the last couple of years, we've seen a real rush to move these data lakes into the cloud and replace Hadoop with cloud object stores, which are currently running at 14% of respondents in our pool. 17% are running their data lake in a relational database, and some of you might think that's an anomaly. But truly, if you use the Inman method of designing a data warehouse, he always called for a staging area, essentially a place where you put your raw data before you turn it into a third normal form and before you create and push out data marts from that. Also, 6% said NoSQL database. That NoSQL database is not an analytical database by any means, but it certainly can hold a heck of a lot of data that can be used for analysis. Second question here, how do most users query the data lake? And this was very surprising. You know, data scientists tend to prefer tools like Python, Perl, Java, and other coding type languages, or in the Hadoop world, Pig, Hive, tools like that, or just plain SQL if the data in Hadoop is written to Parquet files in columnar format. So we were actually pleasantly surprised to see that more than half are using a point-and-click Visual BI tool to query the data lake. So that was surprising. Now I will say, both Bloor Group and Eckerson Group and Arcadia promoted this survey, and we each delivered a equivalent number. So there may be some bias in there, but I don't think too much. So I think we can trust that this data is generally representative of the marketplace. Okay, then we asked where have you deployed your data lake? And you can see here the large percentage is still on premise. Public cloud ranges between 19 and 18%, so less than 20% there, and between 15 and 26% have a hybrid environment, both on-premises and cloud. Now, I just said that we're seeing a large gravitation towards the cloud for running data lakes, but this chart actually contradicts that, and it shows that companies that have deployed data lakes in the last 2 years are more likely to deploy on-premises. So I'm not sure I quite understand that. That kind of runs counter to what we're seeing generally out there, or at least anecdotally, but numbers don't lie, as Eric would like to say. So we'll have to discuss that in a little bit. Can business users explore data to get the views they want? So this is part and parcel of what power users always do, and casual users to some extent do. And you can see here that more than half, almost 2/3, agree or strongly agree with that statement. So the data lake really is an exploration area, a discovery area. And if users are using BI tools, then we have to admit that a large percentage of those users are casual users who do want to do exploration. We're seeing here that the data lake, far from being a data swamp, is actually providing information and data that users find trustworthy and enables them to make better decisions. And of course, that's the whole point of using data, is to improve your decision making, improve outcomes for the business. So it's great to see that over 50% agree and 70% strongly agree with that statement. This is another surprising one, and we asked about query performance, and 50% agreed or strongly agreed with the statement that the data lake provides consistent, fast performance. When you think about it, Hadoop was designed as a batch environment and only recently has become interactive with SQL interface. So things are moving very fast in the data lake world and able to support fast query performance and response times. The next question about the accuracy of analytics in the data lake, that's another reinforcement of the notion that these data lakes aren't data swamps, and that people with BI tools can not only make good decisions, but trust the data that they're working with there. We also did a lot of analysis by company size, and we didn't find much variation between large and small companies, although this chart will show you that very large organizations with over 100,000 employees are a little bit more advanced. 47% strongly agree that business users can explore data to get the views they want, whereas very small companies with less than 100 employees, a good 40% disagree with that statement. We did a lot more analysis, and we're writing a report up on the results. But in general, what we're seeing is that, according to this data from this recent assessment, most data lakes today run on Hadoop on premises. We're seeing that the data lakes are not data swamps, according to some gurus out in the industry, that companies are able to maintain high quality data in the data lakes. And most importantly, they're not just for data scientists. There are graphical BI tools being used heavily that provide fast query performance for queries and exploration. And finally, that the quality of data in the lakes is suitable for regular business users. So I must admit that these results, in summary, and we do have more details in the data, were a little bit surprising to me, but I think it's a good testament to how far and how fast we've come with this new technology, Hadoop, and now the cloud. And I think that is probably a good segue to our next speaker, Steve Woolidge, who can talk about how they're supporting both regular users and power users in data lakes using their Visual BI tool. So I'm going to pass it back to you, Shannon, or Eric.
Yeah, real quick, if I could jump in here and just ask you a couple of questions, Wayne. I'm curious to know, have you found, or what's your take on the people who were involved in these projects? In other words, do you find that the people who were in the data warehousing team are the same people who are working on data lakes? Are they different teams? Can you offer any context on that from your experience?
Yeah, I think in the early days, a lot of the data lakes were started by advanced analytics teams, kind of as experiments to create an analytical sandbox to fast-track the creation delivery of analytical models, predictive models, what we're calling machine learning models today. I think very quickly as those things scaled up or failed, a lot of them did not work out, but IT took over that infrastructure, which makes sense as an enterprise environment that can support either a lot of users, the enterprise, or a very important segment of users, the power users and data scientists. So administering that environment became largely, though not entirely, the domain of IT. Now, Steve may disagree with me, but that's what I've seen today.
Okay.
Yeah, I would agree.
Go ahead, Steve. Yeah.
I would say that we've seen, as Wayne mentioned, the IT teams of as these data lakes have matured, take them over, and that includes other groups I would just mention, like data governance stewards, and you see the BI competency center being involved, and they're sort of choosing standards for these platforms as well. So we'll talk more about that, but definitely, as it's becoming mainstream, it gets woven into the fabric, if you will, of the organization.
I do find that a lot of organizations struggle to reconcile their expenditures on data warehouses and their expenditures on Hadoop. Hadoop obviously is less expensive by terabyte, and a lot of business people look at the budget or the bottom line of these environments and want to replace the data warehouse, but technically that has not really been feasible. There are things that companies are offloading from the data warehouse that probably never belonged there in the first place, or offloading ETL or detailed data. And we're starting to see this bifurcation, at least for now. Things do change quickly, that the data warehouse is well suited for supporting large numbers of concurrent users. We need to do basic reporting and dashboarding, whereas the data lake is suitable for power users and for BI SWAT environments to build things really quickly, prototype them, experiment, test them, deploy them. But now we're starting to see a lot of deployment of standard applications, analytic applications, also happening in Hadoop as well. So I think these two environments are co-opting each other. They're quickly developing the capabilities that the other one has, and they're becoming more and more identical. They'll never be the same, but the dividing line between them is getting fuzzier. But we are seeing Hadoop or data lake taking over more and more of the functionality of analytics.
Yeah, and I guess, and Steve, I'll just kind of throw this over to you real quick before you jump into your presentation. Really, you do want these two environments to be coordinating, collaborating. You want there to be a lot of overlap between them. And it seems to me, and I know that you guys are kind of playing in this space, but from my perspective, and granted I'm in the analyst space, I'm on the outside of all of this, but I see a resurgence in business intelligence, almost like we went down the road of big data analytics. We learned some interesting things, but maybe we're not as tethered to the core business objectives as the world of business intelligence was. And I kind of now see a resurgence of use in BI tools enabled by more powerful infrastructure underneath that can tap into traditional data warehouse environments, but also pull insights from data lakes and from these new environments. Is that what you're seeing, or what's your take on all that?
Yeah, definitely. I think, the power user, I think there's terms like citizen data scientists floating around, which are kind of interesting because a lot of the excitement around Hadoop was getting after all the granular data. There's not some IT department that's pre-processing and telling you what you should be analyzing. it's sort of an exploration area, but I think what's been missing is how do we give that same power to the business users. And then you've got things like machine learning that are being adopted by the BI and analytics tools out there that can speed up that discovery process, can put more power in the hands of these power users or citizen data scientists and things like that. So I think it's just been this natural evolution as kind of the next generation of data people start using technologies like Hadoop and cloud. There's, I think, not to get too philosophical, but there's sort of this generational growth of different technologies that need to keep up with the demands of these different types of users. So, but I do see it coming back to, at the end of the day, SQL is the language that people want to speak, and if you've got a GUI-based tool that can generate SQL that can be utilized by the data warehouse or the data lake, I think that becomes a standard through which you can do your analysis. So, yes.
Yeah, that makes sense. Okay, good. And folks, just as a note here, that assessment which Wayne talked about, from which we got all of that data we were just sharing a moment ago, you will get a link to that assessment in your follow-up email later on this week. So we hope you take a look at that and dive right in and use it really also not just to understand where you are, but to see where you compare to other companies, and you can even do analysis of companies your size, your region, and so on and so forth, industry. So it was designed to provide some really nice granular detail to give you some perspective on where you are in your organization and give you some advice on which direction you should take. So I think it's a very powerful tool, and I would recommend checking out that assessment. So with that, Steve Woolidge, take it away.
Yeah, thanks, Eric and Wayne. And I'm really pleased with the survey because honestly, I've been in this industry 17 years overall. I've been looking at Hadoop, big data, and data lakes for like the past, I don't know, 8 to 10 years, and I've never seen research, frankly, that really gets into the adoption, the usage, what platforms, et cetera, around data lakes. So it's really cool to see this research kind of coming out. And as Eric said, I think there's a lot more people out there using it. I'd love to get the perspectives from folks. But what I'd like to talk a little bit about is what I've seen change in the technology. I've been at traditional BI companies in my past. I've worked for large database companies like Teradata. I've worked at Hadoop distribution vendors, and now with Arcadia Data, we were really built to focus on that challenge of how do we put the power of BI into the hands of people that want to go after these modern data platforms, if you will. And really, let's see if we can slide. What we're starting to see now is that large enterprises, as I mentioned, these BI competency centers, they are choosing new BI standards for their data lake, which are separate from and really not competitive with their data warehouse BI infrastructure, because as Eric mentioned at the beginning, the technology for BI that came out around the concept of the data warehouse was really based on the processing power and memory and things that we had then, and I think there's a whole new world around big data, which is obviously the size of it, but also the variety of the data, the speed at which it comes in, the need for people to have more real-time access, as well as just distributed systems and the whole concept of figure out what questions you need to ask in true data discovery versus, again, having the IT department try to curate and build cubes and things like that that are based on business requirements, but maybe not opening up all the granular detailed data to the exploration that some of these citizen data scientists or power users want to do on all these new sources of information they now have access to. So long-winded way to say that I think times are changing and there is this inflection point. And if you look at the technology history, it's kind of interesting because the data warehouse, relational technology, as Eric mentioned, was built at the time when processing, hardware was really expensive, memory was really expensive, and there was a lot of optimization done at the software level to integrate very, very tightly with the hardware to make sure you're maximizing resource utilization. So those systems tend to be proprietary, which is not a bad thing. They're actually super high performance, but you couldn't take BI server software or a BI server and run it in that same software layer with a database that's running because it was so, engineered for performance. So that's why you've got traditional BI tools that sit on servers or on desktops and will access data in the data warehouse. And there's nothing wrong with that. That's how it was set up. But when you look at the analytical process, you've got to create physical optimizations of the data and how it's stored physically on disk and there's aggregates that are created. You've, of course, got these semantic layers at the BI tool level which connect to different data sources, but a lot of times that data has to be secured and loaded in 2 different places. And when you start talking about real-time insights, the laws of physics state that there's going to be latency as you're moving data across the wire from one system to the other, not to mention the overhead of multiple security layers and models and role-based access controls that need to be connected and kept in sync between these different systems. So when you start to throw big data into this type of an architecture, you've got semi-structured data, you've got these massively parallel systems like Hadoop and Cloud Object Stores, and just the volume of data and the time that it takes to move it, et cetera, you lose that ability to connect natively and do real-time analysis on the system. So when we founded Arcadia Data back in 2012, it was really to solve that problem. And for people that have the data lake in place, how can we give large numbers of concurrent business users access to that information? And the big aha was, rather than having it work as a separate server, let's do what they said Hadoop was all about. Let's bring the processing to the data. Let's build a BI server that is fully distributed, runs in parallel across all the data nodes. So rather than having a separate BI server, we said let's use the servers that are already in place. We'll install and run our software natively on each of those nodes. And when we talk about native BI, that's what we're talking about. It's a BI server that takes advantage of the open nature of open source software and just modern data architectures like the cloud, where you've got lots of processing engines that can run on those data nodes and take advantage of the low-cost commodity hardware. And the resource utilization may not be as highly optimized, but the cost is so much lower, you can just continue to throw machines at it at a fairly low cost and scale extremely well. So that was the big change that we made on the architecture side, which also has huge advantages from the overhead side, where you don't have to optimize physical layers twice. You create a semantic layer once. You can connect natively to semi-structured data. Security is done once. We inherit security from the underlying file system and security systems like Apache Sentry and Ranger and some of those. And you're only moving data once. You put it into the lake and it's there. You don't have to bring it into a separate analytical layer, which just by nature gives you more real-time access to the data. So that's really the architecture, and the results look like this. This is a proof of concept that we did from someone who's now a current customer, a teleconferencing platform that I am not allowed to name, but their requirement was that they needed 30 concurrent customer success managers to be able to analyze the log information around the use of this teleconferencing service to look for bottlenecks or issues when service would go bad and things like that. So they had to be complex queries, it had to be a BI tool, and it had to be 30 concurrent users. And I took away some of the names of the different tools because I'm not trying to point out any issues with SQL and Hadoop engines, but the issue was they were trying to take a traditional BI tool and connect it to a SQL and Hadoop engine, and there was 3 different engines they tried in blue, gray, and yellow, and once you got above 5 concurrent users, the performance degraded significantly and results were not returning. So again, the concept here is that Arcadia Data, or a native BI platform, is not a SQL and Hadoop engine. It's not just doing scans. It's actually optimizing performance and thinking like a BI server that runs in the data platform that gives you that ability to support lots of concurrent business users and accelerate existing BI tools, or we provide our own BI tool, which I'll show in a second. And of course, data doesn't only sit in the data lake, as we talked about. The data warehouse is not going away. It serves a very strong purpose, and workloads that didn't belong there are moving on to other systems. You've also got things like event streaming, which are really popular now. People want to be able to stream data from IoT sensors out in the field and connected cars, which I'll show a quick demo on in a second. But needing to be alerted to, but also see data as it's happening in real time and be able to respond to business as it's happening with the ability to drill to detail in the data lake or connect to other systems, whether it's a NoSQL or a relational system, and be able to visualize all that in one place is a requirement, of course, that you would have in any BI tool, and native BI tools are no different and can support that. So just one last thing on Arcadia specifically is the other thing we really thought about was, I talked about cubes and OLAP cubes and this idea that IT builds these with the business based on business requirements in advance, and they can be fairly complex projects to take on. You build a cube and you're trying to teach people how to fish, but you're only handing them a certain number of fishes within that cube, and every time they ask for more information, you've got to go and hand them more fish or recreate that cube. So what we talked about is how can we give end users granular access to all the data for ad hoc queries in the data lake and provide optimizations as we go on the fly. So we create these things using some machine learning and a recommendation engine. We're actually looking at what are the queries that people are running, what are the tables they're accessing or the files they're accessing, and we'll recommend to the administrator what we call analytical views, and these are caching mechanisms, aggregates, and physical models that will build back on disk in the distributed file system or in the Cloud Object Store. We also take advantage of memory on the machines to make sure that the next time those queries come in, there's a cost-based optimization decision which will route that query to the fastest way to bring it back. So there's no modeling in advance. A human is still involved and can choose the physical modeling strategies, but it's using AI, if you will, or machine learning to recommend the best ways to speed up those queries in the future. So that's smart acceleration is what we call it within our system. That's, again, kind of flipping OLAP cubes on their head. Nothing wrong with OLAP cubes, but it does introduce some form of latency into the process. So speaking of the process, I'm going pretty fast, but you'll get these slides afterwards. I think what we're seeing is if you look at the bottom in white, a lot of people are taking the data lake and they're treating it just like another data warehouse or storage machine, and they're trying to take their BI server and connect to it. And there's nothing wrong with starting that way, but what we see is this analytical process that can really be delayed because, as Wayne referred to, if you're following the Inman model and third normal form and that staging area, there's this process by which you're going to land the data in the lake, you're going to transform it into some model, create this schema that then you connect to your BI tool that's running on a separate server. Just the modeling part of that can take weeks. So the stuff in red, before you can even start to connect the BI server to it, you've got this modeling that's done, and then, oh, by the way, you're going to create cubes on the BI server to speed up performance there once you've brought in the data from the lake in step 5, and then again you've got to secure it in 2 places. So before you get to step 6, it could be weeks or months before you're actually able to do any kind of analysis on data that started out in the data lake, and before you put into production there may be some additional modeling. So with the native approach, again, one system where it's stored and the analytical processing is done there. So we land and secure it once. You can normalize and create schema if you want. There is a semantic layer that can also connect to semi-structured data, structs, arrays, and those types of things. And your analytical discovery process is much faster because you're not moving data. You don't need to worry about the optimizations in advance. It'll run just fine for those discovery queries. And then that AI-driven performance modeling, the smart acceleration that's done, can be after the fact when you decide you want to push something into production. So you're not moving the data. It's one security model. And you're taking advantage of next generation technologies to speed up that analytical process as well as performance modeling on the back end. So it greatly accelerates that time to insight from weeks or months to days. And I can tell you, again, having worked for big database companies, I've had customers I've worked with who said, anytime we need to add a new dimension to the schema in the data warehouse, it's literally 6 to 12 months of time and $1 million of cost. So if you just want to bring in, I don't know, clickstream data into the warehouse for discovery, a lot of these systems and departments have been set up by which, because it's so highly governed, it's just a long process before you can get into some of that. So I think that's why you saw this need for data scientists and the resurgence of, or not the resurgence, but the creation of data lakes where it's more exploratory in nature. So I know we're going to save some time for questions. I'm going to give you a quick demo, flyby of kind of what's possible with a data native technology. We can come back to this, but let me flip over here, and sorry, my email's up here. But this is Arcadia Data, and in this instance here, we've created a couple different demo environments. I've got one on the connected car. There's a cybersecurity application that I won't show here, but I can go ahead and launch this, and this is a demo environment talking about connected vehicles, which it's a very hot topic now, particularly around automated or autonomous automobiles. And you could imagine as a fleet manager for, let's say, I don't know, some service company like AT&T that's putting vehicles out in the world, you want to get some notifications of things that are happening. So you can have real-time event streams that are coming in. This could be coming from something like Apache Kafka. It could be coming in from Spark streaming. People use Solr and indices and things like that for more real-time updates and analytics. And what we're collecting is just information from the vehicles. And again, fictitious data, but we're looking at illegal lane departures in yellow, things in orange are collisions, and hazardous conditions are in red. And we're looking at a map which you can zoom into and look within San Francisco for specific events that are happening. Or I can click on an individual VIN for a car and do a more detailed analysis of the history of that car and what's been happening over time. So this could be across different drivers, and for this VIN, we see all these different events that happened. We've got some scores that are being calculated. These are results of Spark jobs that are looking at the acceleration, aggression score, if you will, for this vehicle. How much has it been accelerating? What's the strength at which these people have been braking, steering, and all these are sensors that are on the device for accelerometers and things like that. And then you can start to do some correlation analysis for those drivers or cars and things like that, and look at things like, is there a correlation between people that drive really aggressively and the number of collisions that they're in? Again, demo data, obviously you would think there's a correlation there, but also gets into things like predictive maintenance and what's the correlation between acceleration and the needing to replace brakes or transmissions and things like that. So as a fleet manager, you've got the ability to monitor things in real time, but also drill to detail, look for correlation and all that within the simple UI. So that's a quick flyby, the types of things that are possible. I saw one question that came in about what industries are these in, data lakes that is, and I think we see it hugely in financial services, telecommunications, government, retail, CPG, all the traditional industries that have lots of products, lots of customers, particularly with IoT and sensor devices. There'll be a lot more growth and things like that. But it really does span all different kinds of industries and different forms of use cases. So just real quick, I wanted to show the tool itself and how easy it is to build stuff. So this is an environment we've got running. It's connected to, or the data, I should say, is sitting in a data lake from a Hadoop distribution. And all I want to do is show you how I build a dashboard. So I'm going to connect to a data source. This is just TV data on viewership across different channels from a TV network. I called it Eckerson TV because I know Wayne's going to get into TV radio again someday. Just kidding, Wayne. But I'm just going to take that data set that's already been connected to. I won't bore you with how we do the connections, but it connects to lots of different stuff. And now I'm going to build a dashboard. So I just click the button that says Create Dashboard. It pulls in the data that's been connected to. So this is looking at session ID, user ID, etc. I just want to simplify that down, so I'm going to click Edit here. I'm going to look at over time, so bring in the date string, all record count for all channels, all programs. I'll just refresh that really quickly. So now I've got a nice simple date string. I'm looking at all the record count over time for that. But, we're a visualization tool, so let's visualize something. We've got something like 30 different visualization types, and I'm lazy. I don't want to try and test them myself, so I'm just going to click on this button called Explore Visuals. And what this does is it uses some machine learning and best practices that are built within the product to recommend different visualization types based on the dimensions and measures that I selected. So here are some different things like bubble charts and scatter plots and horizontal bar charts. There's a calendar heat map, which is kind of interesting, so I'll grab that. And this, again, is just all records over time, but you can see the hotspots of days in the month that were really heavy in terms of people watching TV. So we'd like to try and explore that, so I'll close this out, save it. Let's add one other visual type in this demo, and I'm going to slice it a little bit differently. I'm going to look at channels and programs, and the measures will stay as record count, but I'm going to limit that to the top 50 just to speed up what we're looking at here and simplify it down. So I'll refresh that, and it's churning, but there we've got all channels, different programs, and record counts. Again, nice tabular form, but I'd like to visualize it, so let's see what the system recommends to me. And this is the real data being visualized. It's not just make up thumbnails. I can actually see the results here. I'll go ahead and click the horizontal bar chart. And that looks good. Got different channels, and it's ranked and sorted. So we've got the top 50. So we'll save, close that. And one thing I want to do is add a couple filters real quick, and then we'll open up for questions. But again, just showing how you can connect the data, explore just like you would expect within a BI tool. So let's add some filters. I'm going to add a filter for channel and a filter for program. Save it one more time, view it. So here we have it, and I've got some filters. So if I can see what's happening over all time for all channels. Let's pick a channel. I don't think sci-fi is in here. I'm kind of a sci-fi dork. Oh no, it is. There it is. Sci-fi HD. I've never actually looked at this one. So let's see what are the top programs on sci-fi. So Face Off, Friday Night Smackdown, The Bourne Ultimatum, X-Men. Yeah, so anyway, just kind of interesting. You can see the hot spots. So, this could be used for advertising, things like that, if you're trying to tell someone when they might want to advertise based on the demographics for your different shows and things like that. So, again, simple demo, but it gives you a sense of how you can do this. And this is just, again, Arcadia data running directly in the data lake, giving you access to all the granular data. So with that, I will stop jib-jabbing, and we can open it up for questions.
We do have some good questions here, so let me just start throwing some over to you. One of the attendees is asking about data quality. Where is the quality of data being curated inside the Arcadia architecture?
We do not focus on data prep. That's something that our partners like Trifacta, Paxata, StreamSets, and folks like that will get into. We have a little bit of data prep stuff within it for the business analysts, but we really rely on those partners to provide, again, a native solution that runs within the data lake to do all those standard preparation steps that you would want for more curated data.
Mm-hmm. Okay, and one of the attendees is asking about S3 as a possible destination. Can you kind of talk about your relationship with Amazon S3?
Yeah, absolutely. We have a number of customers that are fully on the cloud. Trying to think of which names I can mention. I think Newstar is one, Turner Broadcasting is another, but a lot of people are starting to store data directly in S3. They still leverage the Hadoop ecosystem in many cases. So Arcadia would run in the Elastic tier and connect directly to data in S3 to visualize it. But that's something we've had for a while, and we just announced support for Microsoft Azure Data Lake Store as well.
Okay, you must have been reading my mind, because that was my next question. Someone was asking, does it work in Microsoft Azure? And the answer is now yes. So let me throw another one over to you. This is an interesting one. We kind of talked about it already, but one of the attendees notes that likely IT people used to working on a data warehouse are going to require a bit of a mindset shift. What have you observed that can facilitate them to kind of reorient themselves to focus on supporting a data lake versus a data warehouse?
Well, I think what's good is that a lot of the skills that those people, whether they're DBAs or what have you, have are completely reusable. I think we're starting to see more and more analytical workloads also moving to the data lake for new applications as people want to build them. And as one of the callers asked about, data quality, cleansing, schema, all those things are still really valuable and important. I think what's changed is just rethinking what's available in terms of BI tools. I think, we were first to market to be able to connect to things like Apache Kafka natively because we're just kind of in that space, and they've got a new KSQL interface that allows you to query streams of information, or things like Apache Solr or Apache Kudu and other types of data platforms that have some benefits to it, and being able to explore data and take advantage of nested data, like things like JSON, structs, and arrays, where you've got the metadata in the data format itself. So you may not need to build a lot of schema in advance, just give the end users more access to it, but you still need to have things like role-based access control and security and things like that. And I think those concerns about security and all those have all been solved by the community. And I think the next wave is just providing tools that can take advantage of those to a broader set. So I don't know if that totally answers the question. I think Wayne probably gets more involved with end-user clients in terms of training and education on.
Yeah, Wayne, do you want to comment on that, Wayne?
Yeah, I mean, I was going to say that you still, you got to pay the piper at some point, and you have to create a schema for this data. I mean, the value of the data lake for power users, it was schema on read, and you didn't have to wait for IT to model it. But, at some point, especially when you're trying to get strong query performance for large numbers of concurrent users, you probably do want to model the data. And that raises a question I had for Steve. When you talked about your smart acceleration, you kind of insinuated that you really didn't need to model the data, that using machine learning, your tool would be able to essentially create caches and aggregates automatically so that you could get up and running pretty quickly, like in a matter of days, without having to do any modeling at all. The tool would essentially create structures on the fly based on queries you feed it, maybe priming the pump, to deliver the kind of performance that users would want. I'm wondering if that's accurate reflection of what your tool does.
Yes, it can certainly do it that way, but it's not pixie dust, right? I mean, you still need, if you're going to have, metadata definitions and data stewards, data catalogs, business terms on, the data and the tables that people want to access. I think you still need that at some level, particularly as once you've done some initial exploration, if you want to provide a broader view to a broader set of people, I think having those definitions and semantic layers and things like that in place are also important. So anything that someone's built in the Hive Metastore within Hadoop or other places, we take advantage of that. Or if they've got a data catalog in place, we can sort of read from that and make that also available. But yes, I think even for those queries then that may have been defined or the tables that have been set, there's going to be acceleration strategies based on actual usage that an administrator may not think about in advance. So we can kind of monitor that, and the system will recommend other ways to speed up those queries in the future. So yes, it can be used kind of on raw data as it's come in without any setup in advance, but it's also beneficial to kind of more of the curated data that will live and support some of these end user applications where you're talking about hundreds or thousands of users on the system as well.
But you don't necessarily require, it certainly wouldn't hurt for users to create a schema inside Hadoop using Hive or whatever, right, to support.
It doesn't require it, but there's value to it, and we can also read it and take advantage of it. Yeah. Yes, it's not required.
Right. Yeah, I mean, that seems to be the trend these days with a lot of these new technologies and tools, is that the processing power is so great that they can deal with the source schema, the sloppy schema that comes from the source, and do something with it and give value pretty quickly. And you can only enhance that value by doing more design up front. And in your tool, you actually help do that as well with the Smart Accelerator capabilities.
Correct. Okay, good. We got a couple more questions here, or several actually. Let me throw in. You've just alluded to this moments ago, but there's a specific question about data catalogs and semantic layers. And what you were saying is that Arcadia is set up to leverage those. How that happens and where it happens in the process, like where it play.
You cut out a little bit there, but I think you were asking where do data catalogs play within all this, or where does Arcadia play within that?
Yeah, you said that you can leverage data catalogs, existing data catalogs. How does that actually work?
Well, so I'm pausing just because I want to. So there's this consortia, for what it's worth, that we're part of called Make Big Data Work. It includes vendors like Trifacta, StreamSets, and Waterline Data. Waterline is a data catalog that was built specifically for data lakes and Hadoop in particular, but there's also Alation Data and others that are out there. So I'm not an expert on those things, but I'm seeing more and more people as they're having multiple systems like the data warehouse and the data lake together. They need common definitions of customer and things like that, and where the data is stored and what data is available where. So we can connect to any of those views and kind of provide back to the business user those definitions that have been defined, access that data, bring it in, and things like that. And then within our own tool, we have a semantic layer which runs directly sort of in the tool in Hadoop, and business analysts can create their own data definitions for tables or data they're looking at that hasn't been defined yet. And there could be, user A in sales is going to name the data one thing that makes sense to them, and user B that sits in, I don't know, engineering might name it something else. So you can also do that at the BI tool level, but there's obviously some, concerns with that if you're a data governance purist and kind of having a single definition for data and things like that. But there's kind of all possibilities, and I would encourage people to go out and check out Make Big Data Work. We've done a kind of a webinar education series in and around data catalogs and things like that in kind of this world.
Okay, good. And here's a good question from an attendee. I think I know the answer, but if you would share it with the audience. From your perspective, what's the main difference or differentiating feature between what Arcadia is doing and what someone could do with a product like Tableau?
Yeah, I mean, the key differentiating feature is the fact that we're a massively parallel system that runs directly with the data. Tableau can cluster environments, but our perspective has been that there's a lot of knowledge about how data is stored on the individual nodes, and our software is sitting there next to the data. We can take advantage of that local knowledge. We're not just passing SQL back and forth through an ODBC driver or something like that. We're kind of running natively where it sits. So that just gives us tremendous scale, performance. It's a lower TCO solution overall. I think it's the architecture that really makes the difference, but then also, as I talked about that process, it really speeds up that time to insight because you don't have any data latency over the wire. You're not needing to move data from one system to another. There's the security where we just inherit it directly from the data platform. You don't have to re-administer it in a separate BI tool. And that's just, it's the philosophy of a native BI solution, which I think is becoming a thing.
Okay, good. And you run both on-premise and in the cloud, right? Can you talk to that real quick?
Yeah, absolutely. I mean, there's, you can get in a long debate on the difference between cloud and on-prem. To us, well, to a lot of customers, I should say, it's just a deployment preference. A lot of people that go to the cloud often start out because they just don't want to manage their own data centers. So you can install our software just as you would anything else in that environment. There's also some advantages that we have in a cloud-based environment that I won't get into on this, but I think there are some, with virtual machine instances and things like that, some different thinking around how you architect software to run in those environments to scale precisely with the workloads. I'll just kind of leave it at that, but there's a lot of things that we do in the cloud that are very interesting. I think our breakdown of people that are on cloud versus on-prem is pretty similar to what you saw in the survey results thus far from Wayne, about roughly 20% cloud and a large majority still on-prem, but certainly a lot of people interested in hybrid and cloud environments. But yes, we can run there.
Yep, and there's another question. This will be the last one I'll throw to you. What about, are you doing something like data virtualization? I think the answer there is no, right? Someone is asking, is it similar to what Denodo does? Your key is giving direct access to the data through this highly parallelized environment, right? Literally taking the processing to the data in a highly parallel way such that you don't need to do virtualization. Is that right?
Correct. And, there's a need for data virtualization or a value to it. I think for us, where you want kind of the physical copies in one place, like that's where you're going to get the huge performance gains. So, obviously we live in a world where data sits all over the place, so there's needs for federation, virtualization, those types of things. But I think for production applications where you want to deploy it to hundreds of thousands of users, again, that's why you would look at something like a native architecture, in addition to the benefits of exploration and everything we just talked about.
Okay, good. Well, folks, we burned through a whole hour. Let me hand it back to Shannon Kemp. Thanks for your time and attention. Thank you, Steve, and thanks, Wayne. Great stuff. We'll talk to you next time. Shannon, take it away.
Thank you all. Thank you, Steve. Thank you, Eric. And thank you, Wayne. What a great presentation. And thanks to our attendees for being so engaged in everything we do and all the great questions that have come in. Just a reminder, I will send a follow-up email by end of day Friday with links to the slides, links to the recording, and links to the assessment for you. We'll see if we can get you a link to the additional demos and such from Arcadia Data. So thanks, everybody. And thanks to Arcadia Data for sponsoring today's webinar. I hope you all have a great day. Thanks all.